Hello students, my name is Soni Bhavin and today we are going to learn chapter 1 number system of class 9. So let us see what does the number system mean. Okay, so in number system basically in class 9 in chapter 1 we have the concept of rational number and irrational number. So main number system is divided into two broad categories. First is rational number and irrational number. Let us see what is the meaning of rational number. Rational number, any number which can be represented in P by Q form, where P and Q are integers and Q should not be equal to 0. Let us take an example. Example is 1 by 2. It's a fraction. 1 by 2 is a rational number here. 3 by 5 is also a rational number. Or 4. We can see that the denominator of 4, we don't see the denominator of the 4. It doesn't mean it's 0. The denominator of 4 exists 1. Always the denominator is 1 for the whole number. Okay. Now let us see the irrational number. The number which cannot be represented in P by Q form is irrational number. Let us take few examples. Example, root 2. Root 2 can't be represented in P by Q form. Then root 3, root 5, etc. Okay. Let us now see the decimal expressions of rational numbers and irrational numbers. First of all, the decimal expression of rational number we talk about is there are of two kinds. First is the decimal expression of the rational number will always be terminating. Terminating means it terminates after a specific or particular digits. For example, 4.2 is after 2 it terminates. After one decimal place it terminates. Second one is 0.56. Okay, so these are the terminating decimal expressions. Another one which comes under the rational number is non-terminating but repeating. Here let us take some examples. 2.333. You can see after the decimal place value the numbers are repeating and are non-terminating. We don't see the terminating numbers here. 3 will be recurring and same 3 number is recurring. That means it's non-terminating and repeating. Here number 3 is repeating. For example, another example is 4.66666. It goes on repeating. It goes on recurring. Then another number is 0.676767. You can see that here 67 is repeating. So in another way we can write 4.6 bar. 6 bar, it has the bar. Above 6 it has bar. It shows that number 6 is repeating here. Then 0.67. 67 has a bar. That means number 6 and 7 both are recurring. Here 2.33 means 2.33 bar. 2.3, sorry, it should be 2.3 bar. Only 3 is repeating. That means 2.3 bar. Only 3 is recurring. Let us talk about the decimal expression of non-terminating of irrational numbers. Such type of decimal expressions are non-terminating and non-repeating. It does not terminate and it does not repeat. Let us take an example. See the example. 0.01. Then again there are two zeros, 1. 0, 0, 0, 1 and so on. Another example is 4.32. 322, 3222 and so on. And another example is 6.05, 0, 55, 50, 555 and so on. Now let us take few examples. How to find rational numbers between any two rational numbers. Now see, there are infinite rational numbers between any two rational numbers. So let us take 5 rational numbers between 3 by 5 and 9 by 10. For solving this, you need to first do, we can see here the denominator of 3 by 5 fraction is 5 and here 9 by 10 the denominator is 10. So let us make those denominators equal. 3 by 5 and 9 by 10. You can see the LCM of 5 and 10 is 10. Let us make the denominator as 10. For that we need to multiply 2 with denominator and numerator. It gives us 6 by 10 here and 9 by 10. So here those both two numbers we have the same denominators. Now we can find the rational numbers between these two numbers. For this we need to increase the gap between the two numbers. Okay, you can see 6 by 10 and 9 by 10 has only three numbers in between: 7 by 10, 8 by 10 and 9 by 10. 6 by 10, 7 by 10, 8 by 10 and 9 by 10. Only two numbers we have between them. So we need to increase the gap by multiplying both the fractions either by 5 or by 10 or by 15 or by 2, whatever amount. If you want 5 numbers, you can multiply it with 10. If you want 20 numbers, you can multiply it with 10. Let us multiply, as we want only 5 rational numbers, we will multiply it with 10. So I am multiplying both the fractions with 10 into 10. So this 6 by 10 becomes 60 by 100, and another 9 by 10, multiplying it with 10 on with denominator and numerator, we get 90 by 100. So our new number is 60 by 100 and 90 by 100. Let us find 5 numbers between them. 61 by 100 is first number. 62 by 100, second number. 63 by 100, third number. 64 by 100, 65 by 100. You can write any number up to 90 by 100. So we have got minimum 25 to 30 numbers instead of finding 5 numbers. But just by multiplying first by making the denominators equal and then multiplying the fractions with 10 or either with 20 or with 100. Okay. So we have got 5 rational numbers between 2 rational numbers. Now let us learn to find the irrational numbers between the 2 rational numbers. Okay, here I am talking about finding the irrational numbers between the 2 rational numbers. See, here we have 2 rational numbers, that is 1 by 2 and 3 by 4. Here you don't need to find the LCM and don't need to make the denominators equal. Here what you have to do is just, now see, irrational number can't be represented by P by Q form. So the decimal expression of irrational number will always be non-terminating, non-repeating. So here you need the decimal expression of both the rational numbers. So let us find the decimal expression of 1 by 2. Decimal expression of 1 by 2 is 0.5 and the decimal expression of 3 by 4 is 0.75. So basically we need 5 irrational numbers between these two numbers, 0.5 and 0.75. Our first number should be greater than 0.5 and the last number should not be greater than or less than 0.75. So let us try. 0.5 is our upper limit and 0.7 is our lower limit and 0.75 is our upper limit. So let us find first number. 0.52 is greater than 0.50. That is 0.52, 0, 5200, 52000 and so on. This is our first number. Then you can use 0.6 is also greater than 0.5, 0.60, 600, 6000, 6000 and so on. Third number 0.64, 644, 6444 and so on. And the fourth number is 0.711, which is less than 0.75. So I can use 0.71, 711, 7111, 7111 and so on. And our last number should be less than 0.75. I am using 0.74, 0, 4, 0, 0, 4, 0, 0, 0, 4, 0, 0, 0, 0 and so on. So the conclusion is that you can find infinite numbers, infinite rational numbers or infinite irrational numbers between the 2 rational numbers. Now let us see how the decimal expression can be shown in P by Q form or represented in P by Q form. Our simple terminating decimal expression, let us talk about 3.5. If we talk about 3.5, this type of decimal expression is terminating decimal expression. Now, expressing this decimal expression into P by Q form is very simple. You need to remove the decimal and write 10, as we have one digit after the decimal. Okay, so it becomes 5 sevens are and 5 twos are. It becomes 7 upon 2. Okay, so this is improper fraction, but the conversion or expression of decimal expression into p by q form is very simple, where you have non-terminating, where you have terminating decimal expression. But if we talk about the non-terminating but repeating decimal expressions, it becomes quite difficult. So let us learn how to express the non-terminating repeating decimal expression into p by q form. Okay, so first we need to assume the number as x. Let 1.2 let x is equal to 1.27272727 and so on. Here number 27 is repeating. Now keep one thing in mind, that we need to multiply either 10 or 100 or 1000 on both the sides, so that we can subtract 2 from 2 and 7 from 7. Here two numbers are repeating. So if I multiply 10 on both the sides, this will become 10x and this will become 12.727. You can clearly see that by multiplying the number on both the sides with 10 will not allow us to subtract 2 from 2 and 7 from 7. So I will multiply again with 100. Let us multiply it with 100. It becomes 100x is equal to two decimal expression will jump on the left side. 127 decimal 27272727. You can clearly see after multiplying the number with 100, we got after the decimal we got 2 under 2 and 7 below 7. So we can easily, this will be our number, equation 1 and equation 2. Let us now subtract equation 1 from equation number 2. Subtracting equation 1 from 2. By subtracting equation 1 from 2, we'll get 0, 0, 0, 7 minus 1. Remember, we have to subtract equation number 1 from equation number 2. So 7 minus 1 gives us 6. 2, this is 0, 0 and 1 is equal to 99x. We have got this. Now, x is equal to 126 upon 99. Now, you can cut both the numbers, reduce the numbers, dividing by 3. So, it will become 42 and this will become 33. 42 by 33. You have got the answer. The value of x when the question has 1.272727 as a decimal expression, you will get the answer 42 by 33, which will be in the form of p by q. Okay. Again 42 by 33 will be reduced by 3 and you will get 3 11s are 33 and 3 14s are 14 by 11. You will get the final answer. Now let us see another question. We have shown that 0.2353535 can be expressed in the form of p by q, where p and q are integers and q is not equal to 0. Here we have, let us assume, let x is equal to 0.2353535 and so on. This is our equation number 1. Remember, here only number 35 is repeating. Now let us multiply the number with 10. Let us assume that the number is multiplied by 10. So this will become 10x and one decimal expression, one decimal number, one number will be jumped on the left side. It becomes 2.353535. See, you can clearly see that we need 3 under 3 and 5 under 5. Again 3 under 3 and 5 again 5, so that we get the answer 0. So let us now assume that we will multiply it with 100x. Let us multiply with 100. It becomes 100x and two decimal expression will jump on the left side. Two decimal numbers will jump on the left side. So you will get 23.5. After 5, the decimal number is 3, 5, 3, 5, 3, 5, 3, 5. So our equation. Now you can clearly see that whatever we have, we want. We got it. Okay, below 3 we get 3, below 5 we got 5. So now let us subtract again. Subtracting equation y from 2. Here 0, 0, 0, 0, 0, 0, 0, 0. 5 minus 2. Remember we have to subtract equation 1 from equation number 2. So 5 minus 2 becomes 3. Then 3 minus 0. 3. 2 minus 0. 2 is equal to 99x. So now x is equal to 23.3 upon 99. We'll remove the decimal and put 0. Our answer 233.990. If it is further divisible, then you have to divide, otherwise this will be your final answer.